In this video, I'm going to be discussing a Sketchpad model that's featured on my blog, Sign of the Times, in a post titled Generalizing the Pythagorean Theorem. If you're viewing this video on YouTube, you'll see a link to the blog post below this video. Normally when we think about the Pythagorean Theorem and a way to visualize it, we imagine a right triangle with squares erected on its three sides. The sum of the areas of the squares on the right triangle's two legs is equal to the area of the square on the triangle's hypotenuse. But what if we'd like to break out from this rather boring illustration showing just squares? Can we put something other than squares on the three sides of our right triangle? Well, here's a picture you may have seen. It's a right triangle, and we have a 2D bust of Pythagoras himself on the three sides. And in each case, we have the same image, but it's been scaled to fit on the sides of this right triangle. And believe it or not, if we were to compute the area of this Pythagoras bust and add it to the area of this one, the sum of these two, and you have guessed it, is equal to the area of the Pythagoras on the hypotenuse. So this is great, but how can students explore this on their own and get creative and decide what they would like to place on the three sides of their right triangle? Well, in this video and in the blog post, I discuss an activity from Karen Wyatt's middle school Sketchpad book where she gives students the tools to construct their own images to place on a right triangle. So let's see how that's done. I'll start by constructing a right triangle. I'll use the segment tool and draw a segment. And let's label its endpoints, A and B. I'll select the segment and point A and construct a perpendicular line to that segment. And now, using the segment tool again, I'll draw another segment from B that extends to a point on this perpendicular line. And let's label this point, which is the third vertex of my triangle, point C. So now we have a right triangle ABC. I'll select this line and hide it. I'll replace that by a segment, and I'll use the marker tool to create an angle marker here, and as I expected, it's a right angle. So here we have our right triangle. Now, to draw an object on the three sides of this triangle, and one that's scaled appropriately, first I'm going to have to use one of the tools that comes with the sketch. And to do that, I come down here to my toolbox, and if I tap here, I have three tools available to me: an 8-unit tool, a 16-unit tool, or a 32-unit tool. I'm going to be simple, and let's just choose the 8-unit tool for now. And now when I move onto my sketch and I tap and I move and I tap again, here I have this 8x8 grid. And I'm going to use this to draw my object. And I'm going to use the polygon tool here. And it was just Halloween, so I'm going to draw as best I can something that resembles a witch's hat. You'll see much more complex examples after I've shown you this one that students have made. So here we go. I guess this will do. Maybe I'll color this black. Okay, so now I have these 2 points in the lower left corner and the lower right that control my grid. And I'm going to hide the rest of these points because I don't want to see them when I create this witch's hat on the three sides of my right triangle. So I'll tap the point tool And then I'll choose Edit, select all points. And I would like to hide all of these except for this one, and the 3 vertices of my right triangle. And now I'll choose Hide Points. So here is my, what sort of looks like a witch's hat. So I want to turn this into a tool that I can now use on the 3 sides of my triangle. So I will select the entire hat and these 2 points. I'll come back here and choose Create New Tool, and I'll give it a name. I'll call it Hat. And I'll move this to the side now. And if I come back here to my collection of tools, I see that in addition to my 8, 16, and 32 unit grid tools, I now have a hat tool. So I'll select that, and I will come here, and let's see what that does. I'll tap on point C, and look, I already see that preview of my hat, which is scaled depending on the location of this point on the right. And I'll attach that to point B. So now I have a hat on the hypotenuse. I'll now start at point B and attach this other endpoint to A. So there's another hat, and one more connecting A and C. So these are my 3 hats. And if I drag my triangle to make other right triangles, those hats scale appropriately. So I'm going to select these 3 hats and choose Measure Areas. And those are P1, P2, and P3. And here are their areas. And if I now choose Number Calculate, and I tap directly on the measurements to enter them into my calculation. So I'll tap on P1, I'll add that to P2. These are the hats that are on the legs of my right triangle. And let's see, P1 plus, oh, wrong hat, sorry, but we can edit that. We don't want P2, so I'll delete that, and I will add P3. There we go. So now we see that the sum of the areas of P1 and P3 is in fact equal to the area of P2, the hat on the hypotenuse. And if I drag a vertex of my right triangle, I see that that relationship still holds. So if you wanted to draw something more complex, you could come here and instead of using the 8 unit tool, you might choose the 32 unit tool, which creates quite a dense grid of points. And if we look at some of the work that students did, that puts my hat to shame. Here we have John Lennon sitting on the 3 sides of a right triangle. Here we have a sandcastle. We have fish, race cars, cats. Really, really imaginative here. Here we have a dragon. And when it comes to finding the area, since students have used here the polygon tool multiple times to construct these figures, it's not just one polygon like I did with my witch's hat. They had to choose which area to measure. So here, for example, I imagine they tapped on the dragon's body and they measured that area on these 3 dragons. And similarly, if we go back to the first one, John Lennon, the student measured just John Lennon's hair on these 3. So there you have it, a really interesting and creative way to explore the Pythagorean theorem, moving away from the boring old square.